All right, so right now we're going to be looking at exponential equation. And we start out by saying that if a to the x is equal to a to the y, then x is equal to y. So in other words, if you have one base on the left raised to a power, and you have the same base on the right raised to a different power, and they are equal, the two expressions are equal, it means that the two powers are equal. So if a to the x, a, which is the base, being raised to the power x is equal to a to the y on the right, then x must be equal to y. All right, so let's look at an application of this, of what I just said. So I'm going to look at example 28, then you can look at 27, 29, and 30. All right, example 28, it says, solve the equation e to the x squared is equal to 1 over e to the 3x plus 2. All right, so first of all, this could be written as e to the x squared is equal to e to the minus 3x plus 2. So that's the first thing. And that is simply applying that. So the objective of the first step is to get the base to be the same on both sides. So now that the base is the same on both sides, if the base is the same on both sides, the powers are equal. So it means that x squared would be equal to minus 3x plus 2. Then I'm going to have x squared is equal to minus 3x minus 2. So all I did there was to remove the bracket by applying distributive law. Then, since it's a quadratic equation, and the first step to solving a quadratic equation is to ensure that one side of the equation is equal to 0. The 3x and the minus 2 on the right, I'm going to bring them over to the left. So negative 3x goes over and become positive 3x, and negative 2 goes over and become positive 2. Next, I'm going to factorize the quadratic expression on the left. I'm going to get x here, 2 here, 1 here, and both sides are plus, and this is equal to 0. So now I'm multiplying two factors and I'm getting 0. X plus 1 multiplied by x plus 2 is equal to 0. And if you're multiplying two things and you're getting 0, it is either the first is equal to 0 or the second is equal to 0 or both are equal to 0. So to finish, we have x is equal to minus 1 or x is equal to minus 2. All right, so we looked at example 28. So now let's have a look at example 27. Now, 4 to the 2x plus 1, plus 1 is the same as saying, is equal to 16, is the same as saying 4 to the 2x plus 1 is equal to 4 squared, because 16 is 4 squared. Now here we have a situation where we have one term on the left, one term on the right, both have on the left and the right side of an equation, both terms have the same base, but the powers are different. Now, in a situation like this, if you have one term on the left is equal to one term on the right, both terms have the same base, the powers must be equal. So the powers, which are 2x plus 1, must be equal to 2. So therefore, 2x would be equal to 2 minus 1. Positive 1 on the left goes over to the right and become negative. And so 2x is equal to 1. And if I divide both sides by 2, I'm going to get that x is equal to a half. So for example 27, x is equal to a half is the answer. Let's turn the page now and look at examples 29 and 30. Now, example 29 is asking us to solve the equation e to the 4x is equal to e to the 12 divided by e to the x squared. Now, in the first thing, it has to be one term on the left and one term on the right. Right now, what we have is one term on the left and two terms on the right. But the two terms on the left, using our laws of indices, can be simplified to one term. So we're going to have e to the 4x is equal to e to the 12 minus x squared. And that is us using the fact that if you are, according to the laws of indices, if you're dividing and the bases are the same, you should subtract the indices, which we did. So now we have one term on the left, one term on the right, both with the same base. Therefore, their powers must be equal. The powers on the left is 4x, and the power on the right is what? 12 minus x squared. So this is a quadratic equation. And the first step in solving a quadratic equation is that one side of the equation must be equal to 0. So bringing over x squared, we have positive x squared plus 4x minus 12 is equal to 0. Factorizing, I need two factors of 12 to give me 4. That sounds like 6 and 2. So x here, 6 here, that has to be positive, and minus 2 here. And this is equal to 0. So I just use the trial and error method to factorize the quadratic expression. If you are not comfortable with that method, you can use the ABC method. All right, so now we have x minus 2 multiplied by x plus 6 is equal to 0. So if you're multiplying two things and you're getting 0, it is either the first that is equal to 0 or the second that is equal to 0. Therefore, x would be equal to 2 or x would be equal to minus 6. All right. The last example from this section, example 30. We have e to the 5x is equal to 1 over 125. So this is the same as saying e to the x, sorry, not e, Lord help me. 5 to the x is equal to 1 over 5 to the third power. So 125 is the same as saying 5 to the third power. Both sides don't have the same base just as yet. We're going to have to say that this is 5 to the x, and this is now equal to e to the, 5 to the minus 3. I think I have e on the minor. So now we have the situation where both bases are the same. And if both bases are the same on the left side of the equation, on the right side of the equation, single terms on both sides, and the bases are the same, the powers must therefore be equal. And in that situation, in that case, x is equal to minus 3.